This video is about design, construction, and application of automatic means failure device (AMF). AMF device or automatic means failure device is used to protect three-phase loads, especially when there is loss of one or two or all the three phases, by switching off the voltage supply to the side load or the installation. AMF device or automatic means failure device is also used to complement the function of ATS, which is a automatic transfer switch or automatic changeover switch, by serving as means failure detection unit and signaling to the standby supply system, which is usually generator, such that the mains failure and the mains voltage supply is switched off while the generator system is switched on. The AMF device also creates awareness of loss of one or two phases or even all the phases, and switch off the main supply such that the generator operator will do the changing over in a situation where the changeover system is manual. Meanwhile, please do subscribe to my JK Multimedia Solutions channel and do follow me in this video. Thank you. Moving on, we talk about the design of automatic means failure device, otherwise known as AMF device. And this diagram represents the design diagram of the device. So, and it comprises a contactor represented by this red rectangle, and then we have three alternating current or AC relays. This is 1, 2, 3. Now, the way it is now, the system is at inactive stage. There is no supply to the load now. So, and let me explain what is happening here. This is the contactor coil, 230 volt coil, and of course it's a three-phase contactor. That's why we have a three-phase supply to it. So here we have the red phase coming here, the yellow phase coming here, the blue phase coming here, and the neutral coming here. And we take one of the phases and wire it as this. So it's such that the wiring connects the three normally open contacts or the three relays. This is the relay 1 normally open, relay 2 normally open contact, relay 3 normally open contact. So the way it is now, in as much as these three contacts remain open, there can be, the contactor cannot be energized and there won't be supply to the load. So the system is inactive, nothing is working now. The same thing, this is a relay. Normally, it's only when power is supplied to the relay that it will function. So this is a soft iron core. When 230 volts alternating the voltage is supplied to the coil, the soft iron core becomes a magnet, and it pulls or it operates the contact of the relay. This is the normally open and this is the normally closed contact. So the three relays, they are same. The relays, the three of them, they are same. So, and this just shows the internal mechanism of the relays. So the way the situation is now, the system is inactive. Now, by the time the supply is switched on, the main supply, by the time it's switched on, there is supply to this the blue phase provides supply to this normally open contact of relay 1, and then just like the way it is wired. So this point here is this point. Why this point here is this point? Because we are dealing with normally open, this and this. So then for relay 2, this point is this point here, and the lower point here is this point here. For this one, this point, the upper point here is this, while this one is this one. So when power is switched on, especially to the three relay coils, when it is switched on, we have power coming to this relay coil. These relay coils, these three, they are this 1, 2, 3. This is the graphical representation of the system. This is the relay coil, this one, and this is this. This one is this. So when the power is or the voltage is switched on, these three relays, they become energized, and all these three contacts, they close. When they close, the contactor gets energized. When it is energized, there is a mechanism, a pull-down mechanism that closes all these horizontal contacts, all these contacts, 1, 2, 3, 4, including the neutral, and there will be supply, power supply or voltage supply to the loads, comprising three-phase load and single-phase load as the situation may be. Now, how does the system work? When if supposing one of the phases is lost, let's say the red phase is missing or it is lost, this relay gets de-energized and this contact will open. When this contact opens, the contactor gets de-energized and there is no supply to the load anymore. If the system is designed to complement an automatic transfer switch, then the generator can start automatically. Otherwise, the system with this contactor will switch off the load and the generator operator will go and switch on the generator in order to have supply to the load. So it is not good to have a three-phase load being run on two phases. So, and that is what automatic mains failure device is doing here. So that is the concept for the design. So, and for the construction, one can get a three-phase contactor. Then the contact rating will depend on the magnitude of the load, and the coil here is a single phase coil. You can operate the three-phase contactor coil. So, but on top of it, we have a three-phase contact, neutral inclusive. And then this is AC relay, 230 volt relay. So it means the coil is making use of 230 as the situation may be. So then one can mount the contactor and the relays on a board, on a circuit board, and then one provides a casing for it. That is an automatic mains failure device. That is what it does. there shouldn't be any confusion here as to whether AMF device is a transfer switch. No. Although it can be done in such that the system, the AMF device, even with the phase sequence device, which we are going to talk about in future, and the automatic transfer switch, the three of them can be combined together to make a comprehensive panel, a complete panel. So, but in this situation, we are just talking of a small device that can switch off the load or three-phase load in a situation where there is a loss of one phase or two or three or even all the phases. And that is the situation. The application is what I've just mentioned now. It can be applied in such that it is used to protect three-phase load, like induction motors or even the three-phase air conditioners and so on. It can also be used to complement the function of ATS automatic transfer switch. So this one serves the purpose of detecting the mains failure, and at the same time it does the signaling to the standby power supply system, which is usually generator set. So, and that is the way it is. So we've gone through the design, and now the system can be constructed, and where it is applied, that is the application of it, where it is used. That is it. And please do subscribe to my JK Multimedia Solutions channel. Thank you, and thanks for watching.